Tell me what you want to hear. Something that life throws ears. I'm sick of all the insincere. So I'm gonna give all my secrets away. This time, don't need another perfect line. Don't care if critics ever jump in line. I'm gonna give all my secrets away.
Mean versus median. Is actually a very good thing going on between these two. Both are measures of center. These are measures of center. You've heard of mean, median, mode. Okay, so the question is, when do we use mean? When do we use median? Well, we use mean, which mean means average. When we have symmetrical data. When do we use median? Well, median, which is middle, or 50th percentile, or quartile 2, we use median for data with outliers and or skewness. And people misuse these all the time. People just use mean a lot. And when we have a lot of data that's skewed or we have a lot of outliers, we really should not be using mean. We should be using median. So when you're looking out in terms of, you know, when they report something, and you know, this is the average, this is the whatever, make sure that you understand that, is this really what I should be looking at? Or should I be looking at median? Okay. Now, the measures of spread. Measures of spread for mean. We use standard deviation, or variance. And I'll talk to you about what is that standard deviation, what is that variance here in a moment. What do we use for median? Well, median, we use interquartile range. Interquartile range, or IQR for short. And this is going to be Q3 minus Q1. And I'll talk to you about what is interquartile range here in a moment. You do not mix this up. You do not say with mean I'm going to use IQR, or median I'm going to use standard deviation or variance. You don't do that. Every time you use mean for a spread, you're going to use standard deviation or variance. For median, you're going to use IQR, interquartile range. Okay? So let's talk about interquartile range. Interquartile range, or IQR for short, is Q3 minus Q1. Well, what is Q1? Q1 is the 25th percentile, or quartile 1. And Q3, think of quarters, 3 quarters, is 75th percentile, or quartile 3, excuse me. Quartile 2 is technically median. And again, we use interquartile range, Q3 minus Q1, with median. Use this with median. Now, something that goes along with that is how do we calculate outliers? Outliers are calculated using the interquartile range and your quartiles. For your lower outliers, you use Q1 minus 1.5, 1.5 times the length of your interquartile range, IQR. Anything below that number is an outlier. And upper is Q3 plus 1.5, so anything above this number. And we're going to learn in the next lesson with box plots how that interquartile range looks like graphically. Okay? So anything above that number is an outlier. Now, this brings us to standard deviation. Standard deviation, we either use S sub x, or sigma. It's a lowercase sigma. Now, which one do we use? In graphing calculators, we always use this, the SX. Okay? The sigma, when do we use that? You don't need to know that until we get later into this statistics course when we're talking about what is the difference between a statistic versus a parameter, a sample versus population. So just know that S or sigma right now stands for standard deviation. What is variance? Variance is simply the standard deviation squared. Standard deviation squared. So for example, if my S is 5, let's use S sub x is 4, my variance, which I call S squared, is 16, and vice versa. Suppose my variance is 49, let's use 20. My standard deviation is the square root of that, which is about 4.5 approximately. So what is standard deviation or variance? Well, I do know that it is dealing with mean. And the definition is it is the average distance from the mean. Now, I want you to understand a couple things that's going on here. Average means you add it all up and divide by how many you have. Distance is never negative. And then mean. This is why you don't mix up median with standard deviation, because by definition, standard deviation is derived from the mean. And the mean, we use either x bar or mu. And again, I'll tell you when we use those symbols. So anytime you see x bar or mu, that is the mean. Okay? So let's continue talking about standard deviation. Distance can never be negative, so standard deviation can never be negative, can not be negative. Standard deviation is greater than 0, except when standard deviation equals 0, and that only happens when all the data is the same. Otherwise, the standard deviation is 0. As standard deviation gets larger, data gets more spread out. And vice versa. As data gets more spread out, standard deviation gets larger. Now, anytime I'm just saying standard deviation here, and you're thinking, well, what about variance? Well, this goes for variance as well. We use standard deviation when we're just talking about things, and we actually use variance when we're trying to calculate certain things in terms of equations and stuff like that. So we're typically going to be talking about standard deviation. That doesn't mean that variance is going to go away. And that brings us to something called resistance, or resistant. Resistant means not affected by outliers. Mean and standard deviation and variance are greatly affected by outliers. They are not resistant. Mean, standard deviation, and variance are all greatly affected by outliers. Median, Q1, Q3, which are also medians, and IQR are resistant. That's why we use mean and standard deviation when we have symmetrical data free of outliers, and we use median and IQR when we have skewed or data with outliers. Okay? And that is it for mean versus standard deviation. You have just looked at the world of mean versus median. Remember, mean, we use a standard deviation or variance for the spread, and we use that for symmetrical distributions. For median, we use that for skewed data or data with outliers, and we use interquartile range or Q3 minus Q1 as a measure of spread. Good luck on mean versus median, and don't forget that standard deviation is the average distance from the mean. Average distance from the mean. Good luck.